Starting off right away, first question on this notes asks you to circle the exponent and put a square around the base. Okay, well we know that the exponent is the term or number that's up floating next to the base, which means here n is the exponent and a is the base. Okay, bases have different rules than exponents, so when we are learning about the properties of exponents, we need to make sure we keep them all separate. We're going to make just another cheat sheet for ourselves here so that you have another set of notes over the properties of exponents. The negative exponent property is that when you have a raised to a negative n power, you're going to flip that to the bottom of a fraction, so now it's in the denominator, and make the exponent positive. Now the second column here says put the rule in your own words. I really do want you to use your own words there. So it's your turn to kind of figure out how you would remember to use this rule. The basic rule is that you cannot have negative exponents in your answer, so you got to hammer time it down to the opposite side of a fraction and make the power positive. Go ahead and pause the video now and write down the rule in your own words. The second property that we've talked about is called the product of powers property. The product of powers property is when you are multiplying like bases together, like a to the m power times a to the n power. The bases are exactly the same and we're multiplying them, so we're going to add the exponents. It's going to be a to the m plus n. So if you're multiplying the bases, add the exponents. Again, go ahead, pause the video, write down this rule in your own words. The third rule we're going to talk about is the quotient of powers property. We use this when we're dividing exponents. Okay, so the rule is that when you're dividing like bases, like a to the m divided by a to the n, since the bases or the letters are the same, all we're going to do is subtract the exponents, top minus bottom. So divide, subtract. Go ahead and pause the video and write this rule in your own words. The fourth rule is the power of a power property. This is the PM part of mad spam. It's when your exponents have exponents. So this is going to be a to the m raised to the n power. So our exponents have exponents. We have powers raised to powers. All we're going to do is multiply those exponents together. Again, go ahead, pause the video, and write down this rule in your own words. The last property of exponents that we've talked about is the rational exponent property. The acronym we use here is TIBO, because all we're doing is rewriting these exponents from rational or fraction form into what's called radical form, where we have the n on the outside and the m still as an exponent on the inside. TIBO stands for top number goes inside and bottom number goes outside. We are just changing it from rational or fractional exponent property, rational exponent form to radical form so that we can take some roots. Again, pause the video, write down this rule in your own terms. So what's really cool, now that we understand the exponent properties and we know what they are, we're actually going to do a visual representation of these exponent rules. So on the inside, I need us to agree on some things. I'm going to be using green squares to represent x's. So all of my green squares are representing x's, and all of my blue squares are going to represent y's. Please notice that one single green square by itself is just a regular x, and if I have two green squares next to each other, that's x squared, x times x. Same thing with the blue squares. This will help us understand why the exponent properties do what they do. Okay, now this is a lot of drawing, so what I'm going to do is I'm actually going to pause the video and draw without you hearing me draw, and then explain number one to you with the visual representation showing. So here's this problem visually. This problem says y squared times x to the 6th, y to the 3rd power. So I have this represented in these boxes. I have my x's represented as green boxes for both of these terms, and I have my y's represented as blue boxes. Okay, we know that if we're multiplying bases together, we're going to add the exponents, and here's why. If we go ahead and write this in expanded visual form, this is x times y, and then x times x times x times x times x times x times y times y times y. That's a lot of multiplication. And so if we just shortened this using the properties of exponents, we would see that there are actually 7 boxes total in this problem. And we would see that there are 5 y's. This is x to the 7th, y to the 5th power. This is the same thing we would have gotten had we just used the multiplication rule, the product rule, where we added the exponents together. 6 plus 1 is 7, and 2 plus 3 is 5. This is why these rules work. The product rule is just adding up the exponents because it's just multiplication. Okay, I'm going to do the same thing for number 2. I'm going to give you a visual representation of what this looks like. That way you can copy it down and then have it as notes. Okay, so here's a visual representation of this problem. I have x squared, y to the 3rd power all over x to the 7th y. Okay, here's what we know about fractions. We know that if we have 5 over 5, that's going to be equal to 1 because it's like the 5's cancel out. Well, that idea of canceling out still happens when we're using variables. Here we have an x over x, another x over x, and we have a y over y. Once we've done that eliminations, once we've reduced those out, we will have y to the 2nd power left on the top and x to the 5th power left on the bottom. 1, 2, 3, 4, 5, 1, 2. This is exactly what I would have gotten had I used the quotient rule. 2 minus 7 is a negative 5, which means it belongs in the denominator to be positive, and 3 minus 1 is 2. These are why we can use these properties to reduce or simplify our exponents very easily. The power of a power rule, number 3, is a little bit confusing. So again, let me pause the video and draw out what this looks like visually. Okay, I didn't finish drawing it out because I want to show you something. This inside the parentheses, yx squared, is represented right here. Wow, I said that backwards again. xy squared, so 1 green box and 2 blue boxes. But this exponent right here says that I want all of this to show up 3 times, because that's what exponents do. They're multiplication by itself. Okay, so let me fill that in for you. Here is xy squared showing up 3 times. Now again, if I just start totaling up the things I have 1, 2, 3 x's, x to the 3rd, and 1, 2, 3, 4, 5, 6 y's, so y to the 6th power. This is the same thing I would have gotten had I just done the power of a power rule where it looks like distribution. 1 times 3 is 3, and 2 times 3 is 6. Okay, that's the power of a power rule. Again, this is why we can use these properties to make these problems shorter. Before we established these properties, we would have had it written out every single one of these in this expanded form so that we could use mathematical properties to reduce it down and simplify it. But if we know our MADSPAN rules, then we're very easily able to do this without showing a bunch of work with the boxes. We're going to continue to do these visually. You may not need to see this if you understand the properties, but it is very helpful to see it visually with the boxes to see why we do what we do, especially when the problems get complicated like number 4. Number 4 has a bunch of terms on there. Let me pause the video and draw them for you so you don't have to sit here and watch me draw them. All right, here's what this one would look like all the way expanded out using the boxes. We have xy squared times yx squared times x cubed all over x squared y. Whew, that's a lot. But if we write it in this expanded form visually, we're very easily able to take advantage of what we know about fractions and canceling things out to start reducing and simplifying this problem. Once I simplify it down, I can just start playing my counting game. There are 1, 2, 3, 4 x's remaining, and 1, 2 y's both in the numerator. So this crazy number 4 actually simplifies down to x to the 4th y squared. I could have used my exponent property rules to count these up. 1 plus 2 plus 3 is 6, minus 2 is 4. 2 plus 1 is 3, minus 1 is 2. So if seeing it visually worked out like this is helpful for you, then maybe expanded form is your game. But if you like using the exponent properties to very quickly get to the simplified answer, I would recommend doing that. Okay, I'm going to put number 5 and 6 both on here at the same time so that you can see them all in expanded form, and we'll talk about their answer. Wow, all right, so here are the expanded forms for number 5 and 6. In number 5, we have 12x squared y to the 4th power, all divided by 3x to the 3rd y to the 3rd times x to the 4th y. Now, once we have it out in expanded form, there's a couple things we need to take care of. First of all, do you notice how you have good old-fashioned numbers right here? When you have good old-fashioned numbers, we're going to treat them just like good old-fashioned numbers. 12 divided by 3 is 4. So we know that our final answer is going to have a 4 in the numerator. The other thing we can do is start eliminating all of our variables. Let's take the x's and start eliminating them as necessary. So we have an x, then another x, and no more x's can be eliminated. Let's eliminate some y's. Eliminate, 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 eliminate. So when I'm finished, there are no more y's left in this problem. There's only 1, 2, 3, 4, 5 x's in the denominator. This is going to be 4 over x to the 5th. Now this problem is a little bit more complicated, so it might be easier for you guys to have it out in expanded form. But if you just took care of the product and the quotient rules by hand using those properties, you'd be able to go straight from here to here without having to draw out all of the boxes. Number 6 especially is annoying to write out in expanded form because we have 3x cubed y to the 5th happening twice, raised to the 2nd power, and we have x squared y to the 3rd happening 3 times. To finish simplifying this, we would just, again, kind of count up all of our x's. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 y's. Now we cannot forget our good old-fashioned numbers. We have 3 times 3, which is 9. So I could have either done the power of a power rule and distributed, air quotes, this exponent on both terms, and then added together the exponents of the x's and y's to get 9x squared y to the 19th. Wow, I said x squared. X to the 12th y to the 19th. Or I can use the visual expanded form and just count everything up. Okay, I went ahead and wrote out the expanded form of number 7, but I want you guys to pause the video right now and see if with the expanded form you can give me the simplified version of number 7. Hopefully you pause the video and you notice that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 x's from x squared y squared times x cubed y to the 3rd power. And there are 1, 2, 3, 4, 5 y's whenever we simplify this out. Because again, I could have just used the power of a power rule and then the product rule to simplify this down. Your choice as to whether you decide to start using the expanded form of all of these properties of exponents or just using all of the rules that we've discussed in class. If you want more practice with the expanded form, feel free to message me on Remind or email me so that I can give you guys some more practice and more examples. If expanded form works for you, go for it. Otherwise, it would probably be much better to use the formula chart rule that we have learned in class.